This video is for lesson 7.5, which is on scale drawings. One of the things that we're going to have to be able to do in this lesson is we are going to have to solve proportions. And so what I want you to do is to try these 6 problems. You may use a calculator, solve for x. If you can, you may use mental math, you may use the multiplication or division property of equality, or some of these you may have to use the calculator and do the cross products. Please pause the video now and allow students to work on these, and when they're done, come back and I will have the answers. Hopefully you had a chance to do this one. I can see that this is times 3, so I'm going to times this by 3, which will give me 24. I'm going to have to do probably the cross multiplying here. 14x equals 140. My answer is going to be 10. On this one, I'm going to have to do 36x equals 720. Divide by 36, we'll get 20. In this one, I'm going to get 3x is equal to 84. Divide by 3, and I will get 28. 14 times 4 is 56, so 20 times 4 will give me 80. And in my last one, 4x is equal to 81 when we divide by 4. So our essential question today is, how can you enlarge or reduce a drawing proportionally? Think about scale drawings. We're going to be talking about these. Scale drawing. It is a proportional 2-dimensional drawing of an object. So the drawing is 2 dimensions. A scale model is similar, but it is a proportional 3-dimension model of an object. So we're going to be talking about drawings, 2 dimensions, and models, 3 dimensions. Also, what we know is the scale is a measurement in scale drawings, and models are proportional to the measurements of the actual object. The scale gives the ratio and compares the measurements of the drawing or the model with the actual measurements. So for example, if the drawing distance is 1 inch and the actual distance is 10 miles, we have a scale of 1 inch to 10 miles. 1 inch equals 10 miles in the actual drawing. So in this, we're going to actually ask, what is the actual distance between Cadillac and Detroit? And you can see right here that they say 1 centimeter is equal to 50 miles. So the first thing that I have to do with this is I have to figure out how far Detroit is to Cadillac. And if you're going to do this, you're going to use a ruler. And it won't be the same as in the book, because this is a little bit bigger, blown up. But what I can tell you is that the distance from Cadillac to Detroit is about 3.5 centimeters in the actual textbook. So now we can set up a proportion. We're going to use the scale here of 1 centimeter is equal to 50 miles. So we can set it up as 1 centimeter is equal to 50 miles, and 3.5 centimeters is equal to d miles, because that's the actual distance. Once we get this, we can take 1 times d is just d, and then we can take 50 times 3.5, and we will get 50 times 3.5 by doing the cross products, and we will get 175. So the actual distance from Cadillac to Detroit in real life is 175 miles. This is a similar type problem. We have the liquid outer core of the Earth is 2,300 kilometers thick. So we're talking about the liquid outer core right here. A scale model of layers of Earth has a scale of 1 inch is equal to 500 kilometers. How thick is the liquid outer core of that model? So what you can see here is I can set up 1 over 500 is equal to x over 2,300, because they told me that core is 2,300 kilometers thick. So that's going to go with my kilometers. So I'm going to find out on my model how many inches that is. So again, I can do my cross products, and I will get 2,300 is equal to 500x. I'm going to divide then by 500, and I will get 4 6/10, or 4.6 inches. So the actual model is 4.6 inches thick. The correct answer is B. If we use the same scale and now know the mantle of the Earth is 2,900 kilometers thick, how thick is the mantle of the model? Again, I'll go back to this one, and we will set it up very similar because our scale is 1 inch is 500 kilometers, but this time we're going to say X over 2,900. And when we do that, we will get our answer of 5 8/10 inches, 5.8 inches. I would like for you to try these 6 problems right now. The scale in this drawing, this problem is 1 centimeter is equal to 4 feet. So they're telling you the model has this many centimeters, this many meters. Please see what you can do on these problems. Pause the video. When the students are done, start the video and I'll have the answers. Hopefully you had time to do this, so we would set this up as 1 over 4 is equal to 7 over 28. 1 over 4 is equal to 10.5 over 42. 1 over 4 is equal to 30 over 120. 1 over 4 is equal to 19 over 7.6. Now, here's where it comes a little tricky. This is 0.4 meters. A meter has 100 centimeters. So 0.4 meters is 40 centimeters. So our answer is going to give us 160. 4.25 meters is going to give us 425 centimeters, which gives us 1,700 feet. So again, you can set that one up as 1 over 4 is equal to 425 over X, which is 1,700. Now we're going to talk a little bit about scale. The scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What's the scale of the model? So again, when I talk about scale, this means the model height over the actual height, which is 10 over 100. And when I simplify that, I can divide both of these by 10, and my scale is 1 inch is equal to 10 feet. The scale is 1 inch for 10 feet. What is the scale factor? Scale factor means that you have to have the same units. So we can't have inches and feet. We have to have inches and inches or feet and feet. So in this case, we know that 1 foot is equal to 12 inches. So I can say 1 over 10 is equal to 120. So our actual scale factor is going to be 1 over 120 because I took this 10 feet times 12 inches. 10 times 12 gives us 120. So our scale factor is 1 to 120. Notice they don't list any labels here because you could put meters to meters, hours to hours, whatever, but they're going to be the same in a scale factor. Scale model could be different. The scale of the model could be different labels. The scale factor will always be the same units. In this problem, a drawing has a scale of 1 millimeter to 20 centimeters. What's the scale factor of that drawing? Again, scale factor, I want them to be no labels or the same labels. So again, how many millimeters are in a centimeter? There are 10. So I would take this times 10, and our answer is 1 to 200. That's the scale factor of that drawing. In our final problem, a common model train scale is called the HO scale, where the scale factor is 1 to 87. If the diameter of a wheel on a model train is 0.3 inches or 3/10 of an inch, what's the diameter of the actual wheel? Set this up as a proportion. Please pause the video, and when students have an answer, please start it up and I'll give them the answer. In this problem, I would set it up as 1 over 87 equals 0.3 over x, or a variable, which would give us 26.1, because 0.3 times 87 is going to give us 26.1 inches. Notice this is an inch, so this label is also an inch. So for your homework, it's from the textbook, page 303, 304, problems 4 through 7 all, and 12 through 17 all. Please go to work on those problems right now, and have a great day.